like I just see a bunch of white. It may have just not been loading right when I was looking at it before, but
mine wasn't clear either. How about you, Theresia?
Oh, mine was okay, but I closed it because I was doing some homework by the time I got home from work before my 6 o'clock other class, actually 6 o'clock my time, but I have another class that has an online meeting right before our meeting, and my computer starts to overheat if I have too many big programs open at the same time. So I have to shut down.
Mine starts freezing and stops working, and it freezes.
yeah, like I've got whatever it has online on the iLearn, and then I also have like 2010 to 2014 is what I can see of the glacier. But there's almost no movement in that, and so I don't fully get what we're measuring.
So when I clicked on the link, it took me to a picture that almost matches exactly what's in the textbook.
Oh, really?
Really?
Yeah.
Wow. Hold on.
Oh, yeah, let me just restart my Google Earth. Maybe something happened.
So I'm sharing with you what I'm seeing. The red and green and white lines are things that I added earlier because I was trying to understand the glacier.
Oh, wow. That looks a whole lot better than what I have.
Your haircut looks really nice, by the way. I've noticed the last couple of weeks your hair's been a lot shorter than what it had been previously. It looks sharp. It looks good.
Thanks. Yeah, I'd hated how long my hair was. I'm so happy I got rid of it.
All right. So that.
Yeah, this looks like it opened up this time with that, like with the same photo you had.
Okay. Pilar, how's yours doing?
Mine looks white.
Yeah, I closed mine and reopened it, and I exited out of Google Earth and reopened it, and now it works.
Okay. And it looks better? Okay, let me try that.
Yeah. Oh. Huh.
So the one that we see, what year is it?
This one, if you look down at the bottom of the screen, it says imagery date 7/1/2014. Okay.
Yeah, 14. Okay.
And then up at the very top, there's the little tabs. There's the yellow push pin, and there's the add a path coming along. There's something that looks like a clock that's got a green arrow going backwards.
Yeah.
That ruins it for me.
If you click that, I just clicked that, and then if you,
you did?
If you click it, and then you can move it down, and it shows you different timelines. This is December 2001.
Okay.
That's 1984. I mean, to me, it doesn't.
When I do it like that, I don't see anything, and I don't even see anything for like the most recent photo. All I see is just it covered in white.
Okay, then it might be that you shifted a little bit. Try zooming out from. Yeah, we might as well. Oh, you wear light. Okay, good. Try zooming out from the image a little bit.
Mm-hmm.
Because this thing that I found is that sometimes when I would change the timeline, it would change the location I was actually looking at, and sometimes it didn't. It left it in the right spot.
If I zoom in enough, it gets rid of all the white, and it turns into that original photo.
Okay.
Yeah.
To zoom in or to zoom out?
So I was thinking something like that shape is similar to what it's showing in the textbook just based on this lower left corner of the picture. You found us.
Hey, Jeremy.
Yeah. Hey, sorry I'm late. I lost track of time. I apologize.
We have not done very much. We're just all trying to get into the right spot.
Yeah.
Okay.
Supposed to draw the lines.
Oh, I just did that because I was trying to understand the glacier. I was trying to figure out, well, which way is this glacier actually moving? So I zoomed out a little bit.
Yeah.
And then I could see that the glacier is actually all the white part to the upper left side. And that is melting down to the right into that little sea or inlet or whatever that is. That's where it is.
Yeah, the sea, the ocean.
Yeah. Then I noticed there's an airplane up there on that other glacier chute.
Yeah,
And there's a
that's
purple cloud that's going on in my head right now. But yeah, that made me smile. So one of the things that I had done, was just playing around with this a little bit earlier just to see, like I said, just trying to figure it out a little bit. And somewhere down in here is a picture similar to what they have in the textbook for us, because they've got that little Y branch over on the far left side. Because it said we're supposed to compare it back to 2001, but that picture's not in our textbook that we have. Ours only has 2000 and what? 2000. I mean, our online program, it only has 2003.
5 and 3, isn't it?
Yeah.
But in his discussion for the week, when he tells how to do the assignments, he had 3 pictures side by side, and it was 2001, 2003, 2005. So I moved my timeline backwards to get to 2001, and you can only get like December. You couldn't get July. And that's what it looked like in December.
Yeah.
And I was trying to understand, looking at the textbook picture, the area at the end of my green and white lines that run from left to right, they're going east and west, that are right next to the whitest part, the white edge, the front edge of the glacier. Trying to use the things that you see along the surface of the Earth to determine how that's different, because on the textbook pictures, I'm sorry, on our BYU Idaho pictures that we're comparing to, that part's white, which is the opposite color for what it is on the Google Earth picture. So that's why I was confused. I was trying to figure out, well, is the white on the text, on the assignment page, the ice flow, glacier, or is it the ice that's melting? And I was having a hard time figuring that out until I zoomed outward from Google Earth, and then I could see that it looks like the white part is the part that's breaking up and melting, and the silvery gray part to the left is just the actual glacier itself that just doesn't have any apparent snow surface on it like it does down at the lower end of the other one. But maybe I'm wrong. But what do you guys think?
I think this part at the end, by the edge, probably that is the recent snow that they had recently.
On the left side or the right side?
On the right side of the picture.
The ones from the textbook?
The whitest parts that is like close to the ocean.
Uh-huh.
The most recent snowfall
Mm-hmm.
had, and because it's getting so warm, part is melting and going down.
Mm-hmm.
is probably the ice sheets, what is underneath the fresh snow. But I don't know. That's
Yeah,
what
I can't quite tell. Like the really white part looks like it'd have to be the glacier to me, but it doesn't make sense because it's just so small. Like it looks like it might be like more.
Yeah.
'Cause, like down at just like the way the flow is coming out, like it's sort of got the fan sort of shape
Right.
coming like with all the white stuff, and so like I feel like that has to be the glacier because it's flowing like that.
And that's
But
what
that's just some tiny thing that's like falling off into the ocean.
So
Yeah.
then I zoomed. So if I zoom out from the picture, remember I had it all lined up so that it looked like the ones from our book. So I've got that little V-shaped thing on the lower left corner by the words that say tour guide, and I kind of have that little ravine thing. And as I zoomed out,
Oops. I didn't mean to do that. I accidentally blocked her. Sorry, I accidentally turned off your mic. Oh, I still have it turned off. Oops.
There it goes.
am I back on now?
There you are.
Yeah, sorry. I
That's
was
okay.
trying to get all your guys'
sure
pictures to go away so I could
myself.
see.
So you probably didn't even need to hear it again. So as I just kept zooming out, that's how I could figure out, oh, even though the coloring is backwards in the two pictures in the book, this really is melting from the north and the east
Mm-hmm.
and flowing out into the sea.
Yeah.
So we're supposed to like do some actual measurements of this.
Huh?
And when
Yeah. Of the
yeah.
receding.
Yeah. And so did either of you guys watch his broadcast on how to do the assignment?
I did not know.
I didn't know either.
This week's been
No.
nuts.
Okay, so I did watch part of it. Not part of it. I watched it. In fact, I watched it a couple times because I was trying to understand this. Because in he was doing things like measuring from, we'll just use this branch, for example, here to here to see how much things had changed and how much it had receded. Because this part of the glacier here, where I just drew that white line, is obviously this little branch is not glacier anymore. It's just that dry bed, and then it's water from there down below. And so he was talking about measuring that distance, and then so I was trying to figure out where that would be, which is why I've got the white line and the red line and the green line in this other area of the main glacier that it pulls up, because I did the red line, I kind of did from 2001, from where this white and gray area starts at the head, out to where it looked like the seawater was starting to come apart a little bit more. So let me see if I can scroll backwards. Yeah, so this is back in 2001. You can see how it's more solid gray all the way out, and just looks like there's little tiny icebergs breaking off out near the tip of the red line.
Mm-hmm.
And then when I zoom time forward again back to 2014, my green line's too short, but it looked to me like it had moved a bit, like it was breaking apart further in toward the main glacier space. Does it appear that way to you guys as well?
Yeah.
Mm-hmm.
And what's really interesting is if you zoom in really close in this area, that's the light gray, surrounding the white, let it settle in, you can see this little pocketing here of where things are breaking up. They had a special term for that melting there. But if you get to a certain point in here, it looks like you can see waves, water moving underneath the dark gray.
Oh
I
yeah.
zoomed in. I saw that.
Yeah. What do they calling that? Rock flower.
Well, rock flower is, I think, the actual rocks. I think these are ice. So those would be icebergs. Rock flower was the debris that's left over that gets tumbled and broken up into a fine powder.
The dust.
Yeah. Because I'm looking further to the right when I've got it zoomed in like this, you can see
The pieces of ice.
yeah, the pieces of ice. I wonder if we can tip sideways. Maybe not. Oh, you see that nice crack there, or right along the straight edge?
Yeah, that's gonna detach soon.
Yeah. So when I was doing the reading, you know, it showed one of the examples was this really tall, it looked like, I don't know, 100 feet tall wall of ice that was the front edge of the glacier, and that things would that would chip off and break off and fall down into the water, and that's why you've got these big icebergs in here surrounded by smaller ones. So those are the parts of that shelf that had fallen off already. And then it was interesting to look at the elevation profile. Oh, come back here. Stop moving. Let's see if we can first. Well, that must be what's going on there, because originally you could see stuff, I thought. Let's try this one. Maybe this one. There we go. So going across the valley, starting from the north side, moving across, or from the south side, moving across, I was amazed at how smooth all of this was. Remember how the areas were in our study of the sea floor, and how the base was like all ragged and jaggedy and up and down,
And that one is super flat.
Yeah, it is, and that's because of the scouring that happens of the wall as the glacier is moving. And that was one of the things that I hadn't realized. It talked about how the glaciers are in constant motion. I hadn't realized that. I thought they just held still, but no, they're in constant motion. And then I was thinking again about this area here where we have this spot breaking off. We could draw a line there. Maybe it'll show us. Not what I wanted. Curious. We can get a look at what that looks like horizontally. So what I'm wondering is, where is that, like the front edge of the glacier? Is the red part the water and the white part's the glacier? Oh wait, so that's the ground still, and it's showing liquid still. So that's not really helping. I was hoping for an actual photograph of what that was looking like, but.
Do you have that line that you drew? Do you have it clamped or to the seafloor or to the ground?
Now I have to remember how to do that.
Right click on the line.
Right click on the line.
And then I think it says something at the bottom, bring up a box or something. It'll say like get info.
Yep, get info.
So then click on that, and then, I'm trying to remember now.
Map to seafloor.
There you go. Yeah, altitude. There you go.
Okay, so this part, how it dips down in here, down lower. It was talking about that's from in the textbook. It was talking about the center of the glacier, just like in a river, moves more quickly than the outside edges would, and so it would be natural that that would have a concave space there. So now I'm curious. Oops, stop.
Like, I think what the lab teacher told us was that just like in a river, like there's a bunch of friction on the sides,
Right.
which slows down the water, but in the middle there's none of that friction, and so the
So
sides go, yeah. That's why there's sort of that like the fan sort of shape that gets produced.
Mm-hmm. So
Like,
what do we?
is it the glacial trough type deal?
Yeah, I think that is correct. The trough. Oh, come back to me. Hold still. So should we start working on our actual assignment for today?
Yeah.
Yes.
Now that we've played around.
Let's measure.
Use some of the features on the valley to note the location of the glacier margins in 2001, 2003, and 2005. So, oops, I think I'm too close here. Let's back out a little bit. Oh, maybe not. There we go. Now we're getting the same picture, a similar picture, because we've got that rounded edge there. Did I go in one more? Okay.
And we got to estimate how much a retreat has
Yeah.
occurred, and discuss reasons why.
So, trying to
So
look.
this one, 2001.
So I think this area, can you see my little hand on your screen?
Yeah.
Mm-hmm.
So I wonder if this area right here matches the area in the textbook that is almost even with, in 2003, there's right where the white part starts. This white part right here is past that. In 2003, it's closer to the opening. In 2005, it's up here like we are now. Need a little more. I'm going to compare this upper area, and it looks like the edges of this area are farther away from the rock mountainous place now than they were in 2005.
Yeah. Yeah, I think you're right.
So how are we going to measure how much it has changed? Ideas?
Can you measure that line that you drew?
I can. Which one do you want me to measure?
Well, what I was thinking is we could backtrack to like 2001, draw the line from the sea to that point, and we can measure that, then draw another one. If that's what the red one is, then we can make like 3 different lines that we can measure each one, so we can see how much it's been retreating
Good idea.
over the past few years.
So the red line I drew,
Does it go all the way to
From-
2001?
that's from 2001. So I started here and I just drew that line up to where I could see the edge of this.
Okay.
Okay. And then I don't know that my next line is as good. But I did not do one for 2003 or 2005. Do you want one for 2000? Which
Yeah.
one do you want?
I think both, right?
What? I was gonna write down our measurements if you wanna
Sure.
shoot me the measurement of the length of the red one for 2001. Is that right?
Yeah, so.
Okay.
How are we going to measure that one? Is there a spot that tells me how long that is? The ruler?
How long the line is? Is that what you're trying to see?
Yeah.
If you do the show elevation profile, it'll show how long the the line is. It probably is in the get info as well.
Stop.
You gotta love how it just moves slow and then it plays catch up.
Yes. Yes.
Yeah.
All right. So
Distance, it says 13.1 miles.
where are you seeing the
This
distance?
is range totals.
Oh, yep, 13.1 miles. Okay, from there to there. But when I'm out this far, it almost looks like that needs to extend further out another, like down to there.
Yeah. Well, we can redraw it.
Yeah, we could.
That's fine. We can redraw it.
Is somebody else, I mean, I'm happy to keep doing this unless somebody else wants to.
Do it.
I'm trying to look as far back as I can, but it's like the pictures aren't the same. It's like I get one from one year and then another from a different year, like right next to each other.
Uh-huh. How does that line look? It's a little bit different angle. Is that okay? Or do you want me to
No, that's fine.
move it around? How about that?
Yeah.
From this point, we're only going to get estimates pretty much on measurements, so we're good.
Right. Blue? Okay. All right, so that's
That works.
2003. The blue is 2003. That's right.
How long?
Blue. Blue says it is 14.5 miles.
14.5 miles. Okay.
Yep. Okay. And that's 2003.
Okay.
And do you want to do a new one for 2001?
Yeah.
All right, let's come in here so that I can delete 2001. Let's draw another one from here. Oh, wait, sorry.
I'm going to change your date, right?
Yes. I need to change the date. 2001.
You're good.
All right, let's try again. If they'll let me do it this time. Here. Think about right here.
What? Looks like it's shorter.
It does. That was one of the things that I was confused about as well because, but then when I was doing the reading, it talked about how that it can shrink and grow. It doesn't just only shrink. It depends on what the snowfall and the temperatures are.
Yeah.
Right.
Yeah, like it says the movements is in like fast surges. So
Yeah.
yeah, I mean it could make sense.
All right. Oh.
All right.
Right. I thought I put that as 2001, but I did not. Try again. Well, let me change its color now. What do I do?
Try like to get info again, maybe.
Okay, here we are.
Let's keep going. It's just being more.
So, all right, so 2001 is red, 2003 is blue, 2005.
You got a measurement on that red one for
Oh,
me?
sorry, I can.
No, you're good. Just real quick, like.
12.9 miles for the red.
12.9. Okay.
I can tell you, I'm gonna have fun with this at our family reunion. Look what I can do on the computer. It's really cool. I'll be the favorite. That's
They're
what I'll
gonna
be.
call you a nerd.
All right, so 2005. We actually have to slide out a little bit more. So we're trying to decide if my line for 2005 is in the right spot or if it needs to get moved. The end of that green line, does it need to get moved to somewhere else?
I would say it's fine. I mean, you're
Yeah.
pretty close.
Yeah.
Right, so the elevation of the green line then, sorry, I gotta get in close enough so I can distinguish it. All right, so that's 10.6 miles long.
Okay.
And,
Okay.
oh, you know what, the green one was 2014.
Oh,
Yeah, because I did that one in green. So
Oh.
sorry. But
okay.
let me do 2005. That was the one we were missing still, right?
Yeah.
All right. Well, it's
Pretty
2005.
darn close, though.
I'm gonna say it's looking pretty similar to me.
Yeah. So 10.6 is what it was.
But I don't know. Or would it be down to the right of these horizontal lines? I have no idea. Those almost look like a photo error.
Hmm.
Would it be further down? Or would it be the same?
I can't tell.
Well, I wouldn't think that they would have those strips in it. I would almost say it needs to be like to the left a little bit. So it almost seems like that green line would be a little shorter,
Okay. This is
is what
2000.
I'm thinking.
This is 2014's view, and the green line is where I had ended it for 2014.
That looks pretty good.
So let's back up to 2005. Where do you want it to end?
Say that one more time, Teresa.
Where do you want the line to end for 2005? Because this is 2005. Trying to figure out where the seawater begins in earnest. This is 2014. Then we have that murkiness with the bars that happens for 2005. Is it going to be down here?
It almost looks like the whole thing freezes more. Like is like this like the whole thing's almost frozen, or am I just sort of like?
I don't know, I'm going up. This
Do
is
you
2006.
do you want to zoom in?
Oh, I can.
Yeah. Maybe if the eyes
I think it's an error in the
in the
image. To see how it's
Yeah.
so particular. Because if I go up to
Yeah.
2007 in that time period, oh look, you can see the crack where things have started to break off. So all of this polka dots, those are all like icebergs and sheets that are breaking off of the main glacier. So 2007 is there. 2014,
it's already melted.
yeah, there's a lot gone for 2014. 2006, 2007, 2005. Where do you want the 2005 line to end? I can't tell.
Oh, I can't tell. My goodness.
It almost looks like maybe like a little bit farther than the red one.
You think it's out here more?
Yeah, that's almost what I'm thinking now, too.
Yeah.
Okay, so let me come back out and I will do another line for 2005. And we'll start it here. And we'll end it right in here. Is that what you were thinking? Oh, down further, down here?
You know,
No.
I can see both. Both almost seem right.
We-
Yeah, somewhere I'd say about in there.
Okay,
Yeah.
bingo.
That's what I would say.
All right, and that's 2005.
What year was the blue again?
The blue is 2003.
Okay. That would make
Well,
sense.
Where did it go? Oh, I didn't hit
Oh.
OK yet. Did it disappear?
It-
Yeah.
At least from our screen.
Yeah, it disappeared from mine too. Try again. And it was down in here somewhere?
Yeah, right in running there.
I
mean-
color.
We-
Okay.
that or not.
So the 2005 one shows 13.9 miles.
13.9.
Yeah.
Okay.
So where the arrow is, don't look at the orange bars down below, but where the arrow is, that is the edge of 2014, of where most of the ocean water starts. And this would be where most of the ocean water starts in 2005, 2001, and out here was 2003. You can't actually see it because the arrow is another. Interesting.
So it's like went back and forth.
Yeah, that ebb and flow
Mm-hmm.
based on temperatures and the snowfall.
Yeah,
Now, when
because from 2001 to 2003, we have a little over 1.5 miles growth, and then it retreated back just a little over 0.5 mile from 2003 to 2005.
Okay. So actually, he said he wants it in kilometers. So let's go back here.
Oh,
Okay.
I had put it in kilometers, but maybe that was something else I was looking at earlier.
Miles, I understand miles.
Yes,
Yeah.
me too. All right. Kilometers. So 2003 is now in kilometers. 2001 is in kilometers. See, I knew I'd done this on something. This blue line. This. Yellow. 2005 kilometers. All right. I know, maybe it's just not the green one. Sorry, I wish I could be faster.
You're fine. You're able to do it also. You can take your time.
Ah! What's
nice.
up with that? Alrighty, nothing like creating havoc and confusion everywhere I go. All right, so our
Mm-hmm.
green one. We should be able to, there we go, show elevation. The green one, no, see, it's still doing distance in miles.
Do the get info again. I think you can change it there. Let me see how to do it.
Measurements, kilometers. It says it's in kilometers.
So,
We'll just do it this way. I just gotta convert, or miles to
Here.
kilometers converter.
try what I just did is I did my line. And here, so like I put in miles, and then let's see, I went to get info, I went to measurements, and it's got what it says, like the length, and it tells me in miles. But when I change it to kilometers, it just gives me the number right there
So you went to
without even going.
and it told you that information.
Yeah, like I didn't do the show elevation profile.
Oh, so maybe if I close
This is just like, yeah, I don't know. It's like if you just go to the measurements, it'll tell you
Oh, I see. Yep.
15.1 or whatever.
So 2001 is 20.8 kilometers.
Oh, that's where.
Okay.
All right, we're getting there. It'll
Yeah.
take us off, but we will get there. 2001 was red. Okay. Blue is 3 is 23.5 kilometers. Somebody's writing this down, right? Because I can't write at the same time.
Yep,
Yes.
I got it.
Okay. The green one is 17.1 kilometers. That was 2014.
17.1.
Yeah. Where's my line? Here. 2005 disappeared. All right. How about this one? Who erased my lines? Could that have been me?
Sorry, it was me.
It was you. I don't think you.
Yeah.
I don't. It's not shared. I think you're just watching. I'm just teasing. This is the one that keeps disappearing anyway, just to make my life hard. Color. Yellow. Okay. Measurement. 20.7 is yellow, which is our 2005.
Okay, 20.7.
Yeah. So estimating how much is retreat. So it doesn't need to be just between 2001 and 2014. What does the math show on that? Who's our math whiz today?
Oh, math? I thought you said map.
No, METH. What is the math difference between 2001 and 2014?
You said the other. Okay,
Red.
never mind.
All right, red is
So-
2001. Green is 2014.
All
How
right.
many kilometers?
So 2014. We got 3.7 kilometers.
Okay.
How many miles is that?
Not sure.
Well, we
How much
could.
is it's just a number to me.
All right. To me as well. So let's look at this red line, and we'll change that one. 20.8. So it's not quite double. So if it was 20 kilometers, it's almost 13 miles. And you
Okay.
said, and how many kilometers was it? You said 13?
3.7.
Oh, 3.7.
I put into Google. It's
About a month.
2.3.
Okay, so 2.3 miles. So that gives a distance.
That's too far.
So in 14 years, that's that much change. I don't know what normal change is. And I know that they can move several centimeters a year, it talked about. So I suppose if they can move that much a year, having it decrease kilometers in a 14-year period of time would be a drastic change.
Yeah.
One of the journals I read this week for my annotated bibliography was talking about this. Okay, I am really not in this screen, really. I delete. Cancel. All right. Is that they talked about how, and they show this in the textbook too, the top layer of the ice may come out to here, but the under layers are much thinner. So let's zoom in really close. And so here we have this straight edge that was the edge of the ice, right? And that might be solid, but but it'll be hollow underneath it. And this grayed out area, remember how we saw that deep concave shape in the, when we did the cross section?
Yeah.
Mm-hmm.
So that's the deep part, and that deep part is melted because water's coming in there underneath, and as it comes in underneath, it starts to melt the under layers of the ice as well. And so if we looked out here, if we could look straight on at that wall, it might be 50 feet tall and reach to the surface of the water, but if you went all the way down to the ground, the ice might not go all the way to the ground right here where the water is. The ice might not meet the ground until way back here where that solid line area is. That might be where the ice actually meets the ground, or even back here at
the end.
where yeah. And that as the ice is melting from the underside, it's dropping sediment that had been collected in the glacier as it's been moving along, as it's been creeping along. So it's adding more sediment and rocks down to the bottom of the glacier as well. So I thought, oh, I actually read something that matched what we were talking about.
Yeah.
So one of the terms that they talked about for as far as motion and melting was an equilibrium line, and they talked about that ablation is where the glacier is melting, and the equilibrium line is kind of like the happy medium between where things are melting and things are accumulating on the glacier. There's like this halfway point, and it shifts as the glacier's moving up and down. What other things can we talk about this? Oh, there's also something about the other edges of the glacier. So coming along in here, I mean, it's interesting to see how the surface area changes too. This is in the winter time, of course, but it comes all the way up to the edges of the mountains along in here. It looks like all that white out stuff that you can't really see.
Mm-hmm.
There you go. This is in June, and you can see the scarring here along the mountain edge.
Cracking, yeah.
Yeah. And you would think that glacier would be smooth, but look at this texturing on here.
Yeah.
Yeah.
I mean, that's just...
And once you get past the snow line area.
Well, remember in the textbook that it said that those shapes are formed by the ice and freezing again and melting and freezing again, and it has that kind of
the pocketing texture to it.
Yeah. So it looks like or somebody's been digging, but it's just the melting and then freezing again.
Yeah. So it's interesting. You can't really see. We're too close to the line, and then as you come out here, I wonder if you can see. No, you can't. Wondering if you could see icebergs, but you can't in this particular picture. But that other one that we were looking at from that other year, I mean, you could see that there were chunks of ice out floating. Yeah, that one. You could see these chunks of ice that had separated from the glacier. An island.
Ablation and calving.
Yeah. And is there? Go ahead.
No, I'm not sure. Is that called calving ice are breaking up from the glacier.
Yeah.
Calvin, right? Okay.
Yep. So that line that we saw, and we said, oh wow, that's going to break off pretty soon. And we could see down here, these have recently broken off. Probably this whole group broke off near the same amount of time because they're all still clustered together near the glacier's edge. But the ones that
I mean,
broke,
the amount of fresh water that is added to the ocean by all this melting of the glacier.
Yeah.
The sea level is rising, right?
Yeah.
There was actually an article in the newspaper here a couple of weeks ago about a place in Miami where the mayors are getting together down in that area of Florida because they're dishing all this money to raise the roads and the businesses higher elevations by putting them on stilts and things because the sea level is rising enough.
Oh, wow.
That inundating the towns, and that the federal government isn't putting any funding towards how to resolve this issue. And so pretty soon they're talking about the mayors from various communities were going to be having to unite to get that resolved and taken care of.
Well, it's going to happen in all the coastal towns once the level of the ocean rises up. They're going to have trouble.
Yeah,
my parents have a beach cabin, and it was about 300 yards, 400 yards from the edge of the sand where you drop down to be where the ocean is. And there were other lower lying, and that was like a 10-foot drop, but there were other low-lying areas in town. And when there were severe storms in the wintertime, the surf's up higher, and if it was a full moon and a storm, then all of their street drains would back up, and so there'd be like 3 feet of water in the street in front of their cabin, just because there was no place for the water to drain from the storm surge.
Yeah.
There's like something like I was here. It's like if the sea level rises like 3 feet, like 4 feet, 5 feet, something like that, how different the landscape will be. Like complete islands will go away. Like vast portions of like Hawaii and like Florida and like anywhere that there's a coast will just be gone.
Yeah. When I visited Hawaii about 10 or 15 years ago with our high school kids on a marching band trip, and it was every afternoon about between 3 and 5:30, it would absolutely pour down rain. And the island we were on was Oahu, and the side of the island we were on, it's just, the mountain is just like right there. You feel like you could touch the mountain.
Yeah.
And then there's this beach around it, and it would hit the mountain and run down so fast that it wouldn't have anywhere to drain. And so they would actually have streets that they closed every day because there would just become a river through the street. And getting to our hotel, you just pretty much had to take off your shoes and wade through a foot of water to get anywhere.
Wow. Yeah, I think like I heard that one of like the most rainiest places on the earth is Kauai. Island of Kauai, because it's got such like a steep face, mountain face. That just shoots and catches all the wind, shoots all the wind up, all the moisture, and it rains like crazy. And like I was at Maui, and yeah, I mean it never like poured really, but every single day for a good like maybe 2 or 3 times a day, it just rained for like 45 minutes.
Wow.
So is there anything else we can notice about the movement?
I have to go. Anything else that we can add?
I don't think so. I think we've talked about a lot. It doesn't say that we have to do a written chart this time. It just says that posting our discussion. So see y'all next week. Oh, go ahead.
Do we need to?
Oh yeah. We probably need
link to your document. Just as a group discuss possible reasons. I wonder if we need to.
I said really fast before I leave.
Okay, I got a pencil ready.
Well, do you want to just type it so you don't have to type it twice?
Do what? I'm sorry.
You want to type it in a Word document so you don't have to write it twice, or do you want to write it down?
I'd have to type or write it down because my computer's running slow right at the moment.
Oh, all right. But we can talk.
I just looked at the
I've caught
document.
bits and pieces of what you guys have been saying. It's come in and out for some reason, and then you start sounding like robots.
Oh, sorry.
No, you're good.
I
Unless
have
somebody
the
else has
document.
got a document up and can go. All right, then go for it. Sorry.
So because of the rising temperatures in the summer, we have all the
So and so that would increase the
Right.
temperature of the water that was flowing underneath the glacier, right?
Mm-hmm.
layer.
Yeah.
And wasn't there something like in the reading too about like the orientation of the Earth's orbit too?
Oh, I did not finish the chapter, so on glaciers yet. So maybe that's in there in the part I haven't read yet.
Yeah, it's at the very end of the reading.
Yeah, with the Earth's orbit. Yeah,
Okay.
let's put it there too. That's one of the reasons.
But two, we talked about how it fluctuates, so it'll move back
Based
and
on
forth too. So
the amount of snowfall and how cold it is.
Yeah.
So how much of it is
Yeah.
freezing versus not freezing.
because I remember, or in the reading, or one of the videos or something like that, it was talking about how like the snowfall would just pack it down even more, so that would just add weight, make it more dense to where it would want to move. And so
Right.
I guess my thinking is depending on that snowfall, it could shift it down more, or
Depends how much snow
it's a thought.
falls
Yeah.
in the zone of.
And if it's wet snow or dry snow, probably
Mhm. Amount of
contributes to
moisture in it.
yeah.
What else was there?
Also, we talked about just the overall temperature in general.
Yeah,
Because if it's warmer, the snow melts more, so it doesn't have as much chance to add to the glacier. Whereas if it's colder, the surface melt would be less.
Mm-hmm.
Because on the pictures in here where we could see that it was pulling away from the edges of the mountainside, I would assume that this upper area used to be up here, and it is slowly shrinking, pulling away, just like like a scab as it's drying on your skin, it shrinks and pulls away from the edges, or the caulk around your bathtub as it shrinks, or around a window will start to create gaps around the edges.
Mm-hmm. The breakaway.
Mm-hmm. Yep. What else did we have? Probably the amount of erosion that happens from calving and the other icebergs breaking off from the front end of the glacier would also contribute to that, because it's retreating the front end as it dissipates, it falls into the sea and flows away. That would make that end of the glacier shorter. So is the terminus going to be the part where it reaches the water? Or is the terminus this point that's the white line along the glacier?
the water.
That's what I
Where it's-
thought.
I think the terminus is like the
Yeah,
would be where like the farthest reach of it.
This flat edge here?
Yeah, I think it's like where that flat line is.
Yeah.
My picture's frozen.
Oh, I'm so sorry. Well, I'm moving around a lot too. I might be causing part of your problems. But
I hate to leave, but anything else that I can add?
What do you think, gentlemen? Do we have sufficient information?
I think so. I can't really think of anything else. I was thinking, you know, like the temperature of the water or something. But that's more where it's located. There's really not a lot of like ocean access to it. It's got to go around a landmass to get to it. But
Right. And in the journal thing that I read, it also talked about the ocean current that happens near the edge of the glacier can affect, because the way that the current brings either colder water from one melts area up into this inlet, or it brings warmer water up into the inlet, which contributes to the melting based on the temperature of the water that the current is pushing into that area.
could do. No, I can't think of anything else, to be honest with you.
Yeah, I think we're good. All right, and you got the measurement in kilometers of the amount that we thought the change in the size of the glacier?
Yeah, I can put that in the document
Okay.
to it.
What I have what I have typed up, I mean, it's basically just the sentences that we said.
I think so.
Yep.
Yeah.
Yeah. All right.
You said
Yeah,
we
So yeah,
could
we can.
All
we
right.
could calculate the volume if we wanted to, but
Okay.
I don't remember the math equation for that.
You can go, Pilar. We'll finish up here real quick.
Oh, I hate
If
to.
you gotta go.
I hate.
I have a
doing
good
it.
week. See
No,
you
you're
next
good.
week.
Yeah,
Thank you. See you Thursday then.
Okay, bye-bye.
you bet.
Bye.
All right.
We are.
Okay.
I am anyway.
Darren, you still there?
Yeah, I'm still here.
Okay.
He talked about calculating the volume of the ice in there. I don't know that that was a requirement. It's not listed. He just said that was one of the things that we could do as we were comparing.
To measure the volume of it?
Yeah, he said you would take a measurement across this way and,
Oh, that must have been in this video that you're talking about.
yeah, and multiply that by this distance.
Yeah, so volume's length times width times height, like roughly.
Right. So we'd have to use,
I don't know
like,
how you'd get the height though.
if you do
Yeah.
the cross section of this line, you could.
Oh, that's true.
Does it show like how high?
So this red line that I drew is like 237 feet on one side. And the line itself is 3.8 miles across.
What?
Wow.
From here to there was 3.8 miles.
Oh, I thought you said 308. I missed the point.
I did it first, and I went, oh wait, 3.8
Mhm.
miles.
That'd be so long.
I
Yeah.
wonder. I know, like on ground, you can do like what do they call it? Like I think it's ground view, to where you can like be looking down a street or something. I wonder if you can shift and rotate and look on ground view on this.
Street view.
They probably don't have that for this.
Oh, there we go. See, I'm on street view.
Oh wow.
Oh, there you go. Yeah, yeah.
I think technically we're underwater.
Yeah, we don't want to be under, right? Oh yeah,
Wow.
yeah. Now we can rotate it.
That's so cool. You'd think that they wouldn't even bother to get those kinds of pictures here, but
Well, I'm sure it's really just computer generated.
you're right.
So yeah, you're probably on the ground, like ground,
let me-
ground,
Yeah, let me
right?
find where I am. I'm lost. That's where I am. Oh,
Yeah, Darren, if you hold down like your little scroll button on your mouse, you can rotate the plane. You can zoom in and then click on your mouse button, and then you can just scroll up or not scroll, but move your mouse up and down, and you'll rotate the plane of it.
Uh-huh.
So now I'm
If that
standing
makes
up.
any sense.
I'm standing on
Yeah,
top.
well, I don't have the mouse, but I see it on like the side.
So this is on top of the glacier now, rather than under the glacier. Oh, so sorry, just a sec. My daughter. Hey, sweetie, can I call you back? I'm doing an online group chat for a few more minutes. Okay, thanks. Bye. Okay,
Look
let's.
at that, Jamie. We're more important than whoever she was talking to.
You are. That's. You should feel honored. That was one of my daughters. You're more important than my daughter today.
Ah,
Oh man.
Quick stretch.
I'm not able to get it to. I can get it to come down all right, but now I'm not getting it. Get me on the ground.
So what I did was I picked up my guy and I drug him to the spot I wanted to stand on.
Oh, there we go.
I got
Whoa.
stuck. All I see is white now. I was playing around with it too much.
So they zoom out a little bit, but you have to make sure that you don't put yourself down in the water because that's
Yeah,
what
if
I'm
you're
learning.
seeing just plain white, you're probably under the water.
Yeah, because
But that is
if
pretty interesting to be able to view that though.
yeah.
Wow, that is awesome.
Who needs to go on vacation? We can just do this.
That's right. Oh man, you can that trough. You can see that glacial trough. If you go into the water and then just start scrolling around, you can.
Right in the center of that gray spot where we decided was the area where the water really is flowing in.
Mm-hmm. That's pretty cool.
I was hoping to get a picture of the
Well,
end of the glacier. That's what I wanted. I wanted to be right on the edge.
That'd be pretty cool.
I don't know if we're really gonna get the volume of it.
So I'll stop playing now. So what?
Do we need to? Do we still need to be live, or can we shut that off?
Yeah, I'll turn it off.